Perfect square binomials and a difference of squares are special products of binomial expansions. An introduction to perfect square trinomials. A perfect square trinomial is created when you multiply the same two terms by itself. So a plus b squared is a plus b multiplied by itself, because that's what squaring means. So you take the first term and distribute into the second bracket, and that will create a squared plus ab. Take the second term and distribute into the second bracket, and again you'll get the ab, and in the end you'll get b squared. The like terms are already collected, so a squared plus 2ab plus b squared. In the second example, the only difference is a negative sign. So it still is a minus b multiplied by itself, and you still distribute the first term and then the second term. And so you'll get a squared minus ab again plus b squared. The similar terms are already collected, so we're going to simplify a squared minus 2ab plus b squared. So you'll see that the only difference between those examples is the sign in the middle. So perfect square trinomials have a characteristic, and it's actually the characteristic that you see here on your screen. The only difference between these two is the sign of the middle term. So each term on the outside is a perfect square. So b squared and a squared are perfect squares. The middle term is twice the value of the square roots of the outer two terms. So that middle term is going to be 2ab. So this creates a situation where you can multiply a perfect square trinomial quite quickly. So I'm going to come up with a third example here, and let's do 2x plus 3. And I'm going to show you a very fast way to come up with the solution. You take the first term and you square it. You take the last term and you square it. Now the outer two terms are always going to be positive. They have to be, because anything multiplied by itself, whether it's positive or negative, ends up being a positive value. The middle term is 2 times 2x times positive 3. So that middle term is 2 times 2, which is 4, times 3, which is 12, times x is 12x. And I've now just expanded my perfect square trinomial. To prove this, I'll write it out and do it the longer way. So I'm going to take the first term and distribute. So there's my 4x squared. Distribute to the second term, and there's 6x. Notice 6x is half of 12. Take the second term, the 3, distribute, and I get 6x again. There's the other half of the 12x, and 3 times 3 is 9. Once you simplify, you get the result that I showed you in green. I'm going to do another one. Let's do 3a minus 4 squared. And again, I'll show it two different ways. You can expand it and multiply, or take the first term and square it. Take the last term. The last term is negative 4. Negative 4 squared is positive 16. The middle term is twice the first term and the second term multiplied. So 2 times 3a is 6a. 6a times negative 4 is negative 24a. So 2 times 3 is 6, times 4 is negative 24a. Notice that the first and the last terms are positive, and the middle term is twice the first and the second. Let's go ahead and expand it just to prove that it works this way. So 3a times 3a is the 9a squared. 3a times negative 4 is negative 12a. Negative 4 times 3a is also negative 12a. And negative 4 times negative 4 is positive 16. The like terms are already collected, so to simplify, you will get the result that I came up with in green. One last example, and I will choose two variables this time. So let's go 2r plus 5q. And just doing it the quick way, take the first term and square it. 4r squared. The second term is 2 times 2r, which is 4r, times 5q, which is 20q, and the last term is 5q squared, so that's 25q squared. Okay, that is a perfect square trinomial. The outer two terms are perfect squares. The middle term is twice the value of the square roots of the outer two terms. So if I square root those, it'll be 2 times 2r times 5q, which are the original terms in the question. So those are the characteristics of a perfect square trinomial. And now I want to look at a difference of squares. Difference in math means to subtract. So it's going to be one square minus another square. That is a difference of squares. And that's actually the solution to a plus b, a minus b. So how do we get there? Well, we take our first term and we expand. So a times a is a squared. A times negative b is negative ab. And now we take the second term, which is b with a positive sign, multiply it by a, and you get positive ab. And positive b times negative b is negative b squared. And in each and every case, when you are doing a difference of squares, the middle terms of the expansion will cancel out. So a negative ab plus b becomes 0. And so the result is a squared minus b squared. And this process works for any difference of squares. It doesn't matter if the plus sign is first or second. So I could say 2x minus 3y and 2x plus 3y. And I know that the solution will be the first term squared minus the second term squared. So to prove that, let's expand. 2x times 2x is 4x squared. 2x times 3y is 6xy. The negative 3y times 2x is negative 6xy. And negative 3y times positive 3y is negative 9y squared. These two values cancel out, and you get the result in red. I'll do one more example, see if you can get there before I tell you the answer. And so my example will be 7q minus 3r, and then 7q plus 3r. And I'm just going to show the answer. 7q squared is 49q squared minus 9r squared. So there's no need to do the full expansion here. Once you recognize it as a difference of squares, you can simply square the first term, square the second term, being sure that you're subtracting one from the other. Thanks for listening.